Okay. Hello, everyone. Welcome to the session. Nitin, our DA trainer or interviewer rather, is not keeping well. Probably has done a lot of interviews. Is not keeping well. He has throat infection, friends, but it's not very severe as such. He'll be back from Monday onwards to excite you all with his witty, responses and questions, etc. For today, we have me playing the role of interviewer, and Sharath would be playing the role of interviewee. So Sharath, we can probably get started now. So when it comes to text mining, we are certain that it's unstructured data. And we also understand that we need to make the data structured to be able to proceed further. May I ask you on what are the various techniques that you apply and what is the flow pipeline to convert the data, which is unstructured, into a structured format? And if you may share your screen with probably the GIF image and then explain, that might help our students understand better. Thank you, Sharath. Over to you.
Yeah, thank you, Bharani. Glad you could connect. Yesterday, I was lone wolf, taking the donning the hat of both interviewers and interviewee. Now the conversation becomes more interesting, and I'm pretty sure our audiences will enjoy the conversations. So let me share my screen. Friends, as yesterday we were trying to understand a few of the concepts of the text mining, the high level flow I was trying to show, give you some insights on how the data looks like, what is the data basically treated, how it is treated and all that. So taking the entire discussion in a phase wise today, as Bernie already hinted, right, the data will be in unstructured format. So to start with, Python will deal with the data in unstructured format, data in string. I mean, the entire text data that we are dealing with is string data. So when we talk about string, it is identifying the string data with quotes. It could be a single quote, it could be a double quote, it could be a triple single quotes, or it could be a triple double quotes, right? So like this, there should be consistency, and anything inside this quotes is string for us in Python. Now, we could have any character. It could be a number, it could be a letter, it could be alphanumeric, it could be a special character. Anything under this quotes is a string for Python. Now, if you want to process or pre-process rather the data, you need to understand how the text is actually written. And whenever we talk about text mining, by default, we will talk about English because that is your computer language. And this is what is used across the globe heavily, right, for computers. So we will try and understand how English as a language is written. To start with, this is called as space delimiter, isn't it? So every word that you see in English is separated by a space. So there is a pattern in which, or a standard, which is used to write, or which is followed to write English language. Now, using this, we split the data. I was explaining this. This is called as tokenization process. Ultimately, I need to break down my entire unstructured data into tokens. But when I try to do this, I will probably get a lot of junk data, right? So what I'll do, I will use the steps. For example, I will have to clean the data. Right. So when I say cleaning the data, I mean, I'm following CRISP MLQ methodology. So I would have to first try and understand if I have typos, spelling correction, spelling mistakes in my data, I'll have to correct that. Then I will have to ensure that the case consistency is there. I also need to understand if there are any junk characters, special characters, punctuation marks, special symbols, all those things. Then anything which is not required from the text perspective, in general, we call this as stop words. And libraries like NLTK, NLP, your text blob, word cloud, all these libraries in Python will have predefined set of words as stop words. We will use that, or we can also use customized stop words to clean the unwanted text. Further, I can also ensure that the text is considered, the tokens are considered in single form of word. When I say single form, I'm talking about present tense, past tense. Different forms of the same word will be there. Ultimately, it is the same word, like mine, mining, right? So these different forms can be manipulated to get single word. That is called as stemming process, right? So talking, talk. ing is basically the extension. So we will take the stem word, cut this all words so that we get significant importance to that main stem word. These are all the various processes that we follow for cleaning the text data, and we can use a library called RE to do this cleaning. Majority of the features are readily available in RE package, regular expression package. That's how I initialize my process, Bernie. And based on my requirement, I would probably deal with advanced concepts like word sense disambiguation, text normalization as well.
Wonderful. Yeah. Thank you. Thank you so much, Sharad. And here, a lot of, okay, let me ask you another interview question on what is the difference between stemming and lemmatization, and what should we prefer?
Thank you for the question, Bernie. Stemming basically is a process, as I explained, to ensure that we get the stem word. Now, this is basically to ensure that the importance to a specific action or a task is captured. A specific keyword, I would say. So, for example, we use the standard example, jump. I could have jumped or jumping. So you can see present tense, past tense, these kind of different forms of the same word are there available in English grammar. These are defined. But ultimately, it is the action that we are speaking about. So we need to capture the stem word by eliminating these leaf words, predecessors. This process of separating is called as stemming, where we consider stem word jump as a repeated thrice. So we are capturing the count. But there are certain words which probably will not give us the same word, in fact. For example, amaze. Or I will say amazing. So if I try to split this word, right? ing, if I split, then I would get a word called amaz. Now, in a dictionary, you don't have a word called amaze, because I'm just removing the predecessor. Sorry, the successor, my bad. The end part. So the word that I'm getting is amaze, which is in dictionary, does not have any definition. Stemming does not look into this particular definition after the split, whether it is coming from a dictionary word or not, right? So that is a drawback that stemming has, which can be overcome by an advanced technique of stemming, which is called as lemmatization. Lemmatization is a way which is basically given for the developers to customize their approach. So we can have a dictionary defined. We can use a WordNet dictionary, which is by default available in the libraries, or NLTK library, or we can use a custom dictionary. And we can do stemming, splitting of the words based on that dictionary. If I have a specific word in my dictionary, only then I will split. Another very good example you can see is city. And if I take plural, cities. Now, if I split this, I get sit. There's no meaning for it. But if I try to have lemmatization performed on this particular kind of word, and if the city word is defined in my dictionary, then I will be able to split the word, capture the original form of the word rather than, singular form of the word rather than plural form. This way, I will be able to manage some kind of customization. Depending on our requirements, we can try and achieve this. Which is better is purely, again, depending on your specific requirements. Bunny.
Yep. Thank you so much, Sharath, for the detailed explanation. I was just making a note of your responses. And when it comes to, assume that you have split the data. Okay. Now you need to convert that into numeric format. What is the flow that is followed, and what is the difference between tokenization and vectorization? Yeah, over to you, Sharath.
Right. Thank you. Okay, so whatever we are basically doing on your data as part of pre-processing, the ultimate objective is to ensure that we get data in structured form. Now, there are many ways to achieve this arrangement. One is basically you can do a key and value pair arrangement. Ultimately, this is what is structure all about. So when you have string, we do pre-processing, that is cleaning, as the various steps that we discussed. You can see that these steps are mentioned here in the data pre-processing stage. After we do this, we can perform tokenization. Tokenization is a process of splitting the cleansed text data into words. Each word is called as a token. Okay, each word is nothing but a token. This process basically allows us to deal with the lowest, I should say, entity of a string, which is a word. When we want to convert the unstructured data into structured format, we can use these tokens by also doing counting. So how many times each token is repeated? So in this case, your key becomes token and the value becomes the count of that particular keyword. This arrangement is also called as bag of words. And if I take this concept and apply it for the entire text rather than one single string, if I take the entire corpus and then try to arrange the bag of words in a matrix format, then I would get DTM or TDM based on the arrangement. And this is your structured arrangement. Now, in this structure, in the arrangement here, you can either use count, that is basically called as your vectorization. You can do the count vectorization, or we can also try and generate normalized values, which is called as TF-IDF concept. We can add weightages by normalizing the count, or we can also try and have the one-hot encoded arrangement, which becomes a sparse matrix, or we can also have embeddings, that is called as a dense matrix. So this is basically the process of converting unstructured data, text data, into structured format. And depending on what we are trying to achieve, either we can do the count or we can do the normalized values, or the matrix can be arranged in either a sparse matrix format or embedded matrix format. But
Thank you so much, Sharath. While Sharath has rightly told that we'll have unstructured data, then we need to perform data pre-processing, then tokenization, then we convert tokens into vectors, which is nothing but collection of numbers. While this is a flow that one follows, what are the various modeling evaluation techniques here? I understand text mining is majorly unsupervised. Nevertheless, when we incorporate supervised learning into that, or some kind of predictive modeling into that. Okay. For example, you probably get emails and then you predict whether those should be spam or not. The moment we bring in the supervised learning aspects, how do you think you evaluate the the model? Yes. No, you are on mute. Sorry.
Sorry, my bad, Bernie. I was on mute and speaking. So based on the evaluation techniques, right? I mean, based on the text data, when we try to build machine learning algorithms, we will use the same evaluation techniques that we used for supervised learning techniques and all that. So if I may give an example of knife-based technique, which is very popularly used for detecting on whether an email is a spam or hack, like whatever we mentioned. The use case that you're talking about, detecting a mail as a spam or a hack. We can probably look at the accuracy of the models based on the probability that we are getting for each word. I mean, ultimately, we use training data, test data, we try to predict the results, and based on that prediction, we will try to measure the accuracy, and all these things come into the picture. And it's just a supervised learning metrics that we use for even for knife-based kind of an example. The data that we are using is, in this case, is text data. But if I have to talk more about, say, for example, the sentiment analysis, right? The sentiment analysis, one of the primary application in text mining scenario, text mining area. And it is heavily used even in chatbots. Or you can also evaluate how a product is performing with respect to its acceptance in the market. The customer's feedback can be analyzed and understood whether the customers are happy or whether they are not so happy, any specific feature is not good. So we are basically performing unsupervised learning techniques here to analyze the feedback, and that is your sentiment analysis. And this same concept can also be further taken in the chatbots. Here, in generative chatbots, we also have advanced NLP techniques which can try and use this sentiment analysis related scores to also try and predict on what kind of questions we may get from the user. And I mean, this is just an example that I'm trying to quote. If, say, for example, a user is talking about a product on e-commerce product, let's say e-commerce chatbot, and the user is speaking about a specific product, maybe a t-shirt. The color of the t-shirt could be one of the entities that the user probably is citing. Right? And when the user follows up with respect to the same question on what could be the size of this particular shirt, this shirt could be referring to a shirt which was previously being discussed. In that scenario, the color could be one of the primary aspects that we are trying to discuss. So your chatbot, which is based on the NLP or text mining concept, NLP concept, the agent should be able to correlate all this discussion, and this shirt reference has to be mapped back to the color of that particular shirt, because there could be many different shirts that the user could have been speaking about in the previous instances. So this kind of a mapping has to be done, and the scores have to be calculated for each of this. And in short, we are basically using probability, which is the primary key which basically is used in knife-based algorithms as well. for mapping these kind of things, and the probability is what we are going to use as a metric for measuring the accuracies as well. You can also talk about the same application and the sentiment analysis application in the stock market as well as another example. I mean, again, the applications are so wide that we can take many instances as examples. Recently, we have seen that Facebook has Meta has laid off a lot of employees. Close to 13% of the staff has been laid off. And there is a lot of speculation which was happening even before the incident happened. We can perform sentiment analysis on these speculations, the statements that are being coming from the management of Meta. And we could even do the prediction on whether this step would have been actually been implemented or not, or maybe this is just a statement which is given for improving the performances of the employees or improving some kind of a sentiment in the market so that Meta's revenue could increase. Right. So these are some of the applications that I'm talking about.
Yeah. Sharath, and you have also worked upon multiple projects when it comes to text. And one of those is for a client called as SKP Group. And one another thing is pertaining to the chatbot.
That's good.
So the AI tutor chatbot. Can you throw some more light on that? On what was that project all about and how text mining and NLP was used to, build a model around that? And also for the Malaysian client, which is into news, right? So can you throw some light on that?
Yes, definitely. I will start with the news particular project, news project. So this was a project that we were talking about creating content for the news agencies, one specific news agency. So that, I mean, if you talk about the news platforms nowadays, everything is on OTT, everything is digital platform. So in order to ensure that the news gets more traction, I mean, that's how the channels make money, right? Their news has to be consumed by majority of the people, the TRP data. So what text content or what sentiment should be there in the news article is something that we wanted to build. So there were a lot of prediction models built. There were a lot of sentiment analysis models built. And a lot of web scraping was also performed here in order to understand when an incident happens, we perform a lot of competitive analysis and try to understand what content, what sentiment is getting more popularity. So the incident or the event is one event, but different news channels try to project that in different ways. We were trying to capture all that information, and we did sentiment analysis and scoring with respect to the polarity and subjectivity of that particular article. And we were also trying to capture what kind of traction each of that article was having. By using some Google APIs, we were doing that. And depending on all that information, we were trying to generate an article by the AI system by taking all the information, bits and pieces of information from all these different articles. So there is something called as text summarization concept that was also implemented, which generates a very simple text summary of all the story from different articles that we have picked. And this was also incorporated with LSI keywords so that when this article goes into the platform, news platform, automatically majority of the people will be able to capture this news when they search. And this way we were able to try and attract more eyeballs for the news articles that are getting published by this news channel. The another project that I was part of was with respect to internal auditing related work, right? Auditing. So auditors do benchmarking for various their auditing standards. Every organization will be benchmarked. And depending on that, there are internal standards which are defined, internal processes that are defined for that company. And I'm not getting into many details. But there is a specific process by looking at the organization's definition. When I go to any website, any company's website, I will know what is they talk about. Right? You can just get a hint of that by reading the About Us. So you go to the organization's website, try to capture their vision, their company's objectives. And along with that, we also tried to capture the revenue, year-on-year revenue that they make. And what are the primary channels of this revenue that is getting generated from? Everything is text data except for revenue. And using all this information, we have standards to benchmark the organization, whether to consider that as a specific standard benchmarked level. There are different levels. So which level should we benchmark that particular organization as? Is something that we were able to do by analyzing the text data and these channels. So NLP models were used here as well. So this is a couple of projects that we have worked on, and with respect to the AI tutor, again, we are using generative chatbots here, where depending on what kind of question, any open-ended question that can come from a student, for example, can be addressed by going through the corpus of the trainings. So as a trainer, if I have some content, some question addressed, and when a student comes with a question on that topic, related to that topic, then analyzing that corpus, my answer, we will be able to generate an answer to return that answer for the open-ended question that a student is asking on the same subject. This is done using something called as generative chatbots. So a lot of NLP and corpus has to be designed from video and various textbooks, you can say, the books corpus. All these corpus was taken, and then we generated these answers. Bunny.
Yep, thank you. Thank you so much, Sharath, for that amazing explanation about the multiple projects that you've worked on textual data. And it is extremely imperative, friends, that as a data scientist, you also understand about working on textual data, because a lot of data which is getting generated nowadays is in textual format. So one should be aware of how to analyze the textual data. And I think you guys, should take a lot of inspiration from this discussion and start working towards that. All right, friends, thank you so much for now. And please do subscribe to our channel, follow our pages, inform to your friends, relatives, well-wishers about this. And we would continue doing these throughout. Okay, there are a lot of amazing, interesting interview sessions which are planned, and you all will reap benefits from that. Thank you all so much, Sharath. Thank you, Sharath. Thank you, everyone, for watching this. Bye for now.
Thank you, Ahul. Thank you so much. And subscribe, comment, and like the video, friends. See you all.